Welcome everyone, my name is Felix Rosbach and I'm working at the product team here at comforte. In this Lightboard series we are talking about data security, and this video is all about tokenization. So when it comes to protecting data, protection solutions like encryption or hashing have a long history, but solutions like tokenization have only recently come into focus. And given the multitude of options you have to protect sensitive information, it's really hard to understand the differences and the properties of all those protection methods. So what is tokenization? If we look at the basic principle of tokenization, it's all about substituting an element with a token. And the token itself, from a security perspective, doesn't hold any sensitive information, but it maps back to the original element. So we know tokenization from various different use cases. For example, in blockchain, where we have real-world assets that are substituted by a token, like a placeholder, to be recorded in a blockchain. Or we know it also from payments tokenization. For example, Apple Pay, where we substitute our card holder details when it comes to sending them to a merchant. So the merchant only holds the tokens and doesn't have any sensitive information of us. But today we want to talk about tokenization in terms of data security. So in data security, tokenization is used to secure any type of sensitive information that is structured. For example, PII data, or healthcare records, or payments data, or any kind of sensitive information. So what is needed to tokenize data is basically a tokenization system. And this tokenization system does not only do the operation to tokenize data and creates the tokens, but it also provides the interfaces for all processes and applications and instances in your network to basically contact the tokenization system and do the deprotection or protection operations. And the good thing with most tokenization systems is that they allow you to determine how the token looks like. As an example here, we created a token. And one of the main benefits of tokenization is that it's format preserving. So applications are able to process the data to run on tokenized data instead of the clear text data. And this basically reduces the exposure of sensitive information a lot. It's also easing the process of implementing the security method because you basically don't have to change applications. Another main benefit of tokenization is that you can keep parts of the information visible. While the token is still secure and hackers can't do any fraud with it, the part that is kept visible allows processing of data or data analytics, for example. When it comes to environments that need high performance, tokenization is also a good choice because tokens can be processed very efficiently. So how does the tokenization system work? There are actually many different ways to implement tokenization. One option is to use a tokenization vault to map data elements to tokens. And this method is called on-demand random assignment-based tokenization. For every new data element, you create a mapping in a database. And if you want to deprotect again, you have to perform a lookup in this database. And this results in a database that is constantly growing over time. And with that, it becomes a stateful tokenization scheme. So it's really hard to manage and you have to synchronize the database across all instances of the tokenization system. Another option is to use a stateless tokenization scheme. So in a stateless tokenization scheme, there are two different options. One option is to use a static table-based tokenization. A static table-based tokenization scheme uses an algorithm that runs on static predefined tables. And those tables do not hold any token mappings, but random values that basically are the secret of this algorithm. And as the table is static, it becomes a stateless tokenization scheme, and it's easy to distribute it to all instances. Another option is to use encryption-based tokenization, or so-called format-preserving encryption. And format-preserving encryption enriches or enhances the capabilities of encryption, classic encryption technologies like AES, for example, to be format-preserving. And the key that is used to decrypt or encrypt is basically the secret in this tokenization scheme. So a tokenization system can be implemented in various different ways. And the flexibility, scalability, and also the security of such a system really depends on which method you are using. It's also important to think about secret isolation, but that's a topic that we will cover in another video. For now, we just can say that tokenization is a really good method when it comes to protecting structured sensitive information and reducing the exposure of sensitive information in your network. It's also a very powerful method when it comes to data-centric security. So thank you for watching, and see you in the next video.